Welcome guys, in this tutorial we will go in the details of the basics of ETABS for modeling. Let's get started. We will design this building consists of 5 floors, and we will design the frames, columns, beams, and slab also. Okay, so let's get started. First of all, we need to create a new model. Once we created a new model, we would like to save that model in our directory. So we will have like this window. So need to use a built-in setting. The metric is a unit, and I would like to have the code for the concrete to be the updated ACI 318-19, okay? And after that, we will have like the grid system. So our grid system assumes we'll need this grid system 4 by 4 and each 8 meter. The story height be 3 meter, 3 meter, and we have 4 stories. Once we did that, we can click on OK. Okay. Now we can also view the grid system and the 3D view. I have this window for the plan view, and I have this window for the 3D view. Now I would like to define the materials. So after we open the material property data, we need to define the property. For example, I would like to have a C for concrete, 28 megapascal. Can name it like this, and it's a concrete. Then the unit weight per unit volume, or the weight per unit volume for reinforced concrete is equal to 25 kilonewton per cubic meter. The modulus of elasticity for concrete is given by the formula per ACI standards. So we have 4,500 by the square root of f prime c by simply the multiplication sign in your keyboard, and then the f prime c to be 28 to the power 0.5 to have the square root, and press enter. Make sure it is the power sign to 0.5, enter. So this is the megapascal. I can remove the digits to simplify the value. So it is 24,870. Okay. Leave everything as mentioned in the ACI standard by default for Poisson's ratio, coefficient of thermal expansion, the shear modulus, P, and it's already defined. Okay. Once we did that, we need to go to the design property data, and then we can name it the grid for, I don't know, let's say 28 megapascal, and it's just like a description. And this is the value that you need to go change, is 28 megapascal, and then click OK. After you do all of these things, just click on. I can make a copy to have, for example, 30 megapascal, C 30 megapascal for column concrete, for example, if I would like to have different concrete compressive grades, okay? And leave the unit weight gamma to be 25 kilonewton per cubic meter, unit weight of concrete, reinforced concrete. But we need also to change here modulus of elasticity because it depends on f prime c. So again, it is 4,500 by the square root of f prime c, 30 power 0.5. Press OK or enter. You can remove the digits. And here also we would like to change it 30, and here we have 30. In some concrete grades or in some concrete types, we have a lightweight concrete, but here we have a normal concrete. We don't have a lightweight. If it is a lightweight concrete, you would like to have or to click on that tick, okay, like this. For now, I just finished defining the materials. Now I would like to define another material for steel, because we have rebars reinforcement. And then I would like to have that definition for this material. So you can name it like rebar, for example, G60, E for grade, and 60 is a value of KSI, kilopound per square inches, okay? And convert from kilopound per square inches to megapascal, you just multiply by 7. This is just a conversion factor. And the unit weight per unit volume of the I'm sorry, I would like just to add a new property, or just copy the grade 60 here, because it's already defined the unit weight of the steel before grade 60, because I just make a copy of the. Now I would like to have the steel defined. So go to grade 60, add a copy, and then it's already given, or I can just input that value, which is 76.9 kilonewton per cubic meter, which is the density, okay, for the steel grade 60. Again, just make it grade 60, for example, okay, and once finished, the modulus of elasticity, you just keep it, or it's given by, normally given by 2,000 to 100,000 megapascal. Okay, this is just for the grade. but by ETABS it's like the 200,000 meg. Okay, so it's just like approximated, so it's okay. Don't worry about that. You can just leave it as the previous value, or just keep it as 200,000 meg. Okay, and just design the design modify show material property. Just change the yielding, because for grade 60 the yielding would be 60 by 7, which is evaluated or approximated to be 420 megapascal. And everything is another these factors. Just leave it as default, because you don't need to worry about this, because the most critical one is the efficiency. Okay, and then it's okay. We just define the area. Once we did that, now we would like to define section properties. Go to define menu, section properties, frame section. I have a lot of sections here, okay? But I would like just to get rid of all these sections, because I need just to focus on the design sections, design dimensions that I would like into my structure. For example, I would like a beam to be 0.8 by 0.2 or by 0.25 meter, and I don't need to have all of these factors and all of these dimensions that already defined in it. I just would like to clean my window, go to detail, go to delete multiple properties. Once you did that, sorry, again, you need to just select them. First of all, go to the first one and just move to the last one and click shift. After you click in this, again, click in the first one and click in the last one by shift, and then delete frames. And also you have these sections, so again, shift, and after you scroll down, shift again, delete. You will have like this message, because ETABS need at least one section to be defined, not delete all of them. Okay, we can just click on OK, and after that we have just these defined by default at least one section. Okay, now it's okay. Again, define section, frame section. Now I would like to add a new property. Okay, add a new property. So add. I would like to have a concrete and rectangle shape. So after that, you click on that. I would like to have a column, for example, C for column. It assumes our column is 0.4 x 0.4 meter dimension. Okay, this is the cross section that I have. And the material of concrete, I would like to have 30 megapascal for columns, and for beams and slabs, maybe I would like to have 28, and maybe 35 megapascal for foundation. I can also define. And simply because I missed to define the footing concrete, I don't want to go again and close this window and go again to define material properties. But from there, I can just click in these three dots and add material. Add a copy of this 28 or 30 megapascal and just name it like 35C 35 megapascal, just like that. Okay, and just would like to gain 4,700 by the 35 to power 0.5. Okay, and just get rid of these digits. And finally, I got that, and here just name 8, 35, sorry, and 35. Okay, perfect. So I defined this material. But for column, because I'm defining a section column, so I need to take it 30 megapascal for now, because foundation needs to be larger, okay, for compressive strength. And the dimensions. So the dimensions, I would like to have the dimensions be 400 millimeters by 400 millimeters. Why? Because I'm defining a column 0.4 by 0.4 meter. So it is 400 millimeters. The modifiers. Go to modifiers, and this is the modifiers for the capacity to ensure the cracking cracks in the column, cracking subject. Because column will have shear forces, and these shear forces becomes cracks in the column. So I need to consider the cracked stability and so forth. So the modifiers, stiffness modifiers for columns according to ACI code equal to 0.7 for torsion, also 0.7 for the moment about 2 axis moment of inertia, and also 0.7 for the moment about 3 axis, which means just 70% of the capacity for moment of inertia about 3 axis, and also 0.7 by the moment of inertia about the 2 axis, and the torsional capacity be just 70% of the normal capacity. This just to consider the shear forces, the cracks, and so forth. Once we did that, just click on OK, and then go to the reinforcement. because we need to define the minimum reinforcement, okay? And the minimum percentage reinforcement for columns to be 1%. 1% means I have 400 by 400. So this is area growth. And also we can view this area growth. We go to show section properties. Here the area growth in centimeters square, or okay. Also we can change the units from here. Also we can view it in centimeters square. And this is just the area growth. 1%, 0.01 from this area growth will becomes the reinforcement of the section to be minimum, defined by ACI standards to be minimum 1% of the area growth, and the maximum allowed is 8%. But for practical purposes, we need to be more economical in the design, because steel has like 3x 3x of the cost, okay, 3x cost than the concrete. So the concrete is cheapest than the steel. So we need to consider that in economical side. So just click in the reinforcement, and here I would like to make sure it is a column, not a beam. And I just need to make sure the grade 60 steel that I defined. Then I need to compute the number of rebars that evaluate to 1% of the area growth. Okay, so I have the area growth. I have the 1% area growth, which is area of steel. I can divide by the cross-sectional rebar area, so I can define the number of rebars to be even number, not an odd number. Because if I have 17 rebars, okay, I need to make it 18. So it assumes it's evaluate to 3 and 5, 3 here and 5 here. So I have, okay, and here also we can choose the rebar. It assumes it's 18 millimeters squared, so it's defined here the cross-sectional area of that rebar size. And also for the confinement or the stirrups, we can choose 10 millimeters, or maybe in some buildings we choose 8 millimeters. And this is the spacing. Okay, this is the spacing here, millimeter, 15 centimeters or 150 millimeters between each stirrup. And then let's okay. And finally, we define that section. By the same way, we can define the again, we can define, add a new copy, add a new property, or we can just add a copy of that property. Define the beams. So let's assume we have a beam 0.8, okay, the width, the thickness. It assumes we have like a solid slab, or no, we have a ribbed slab. The ribbed slab thickness of the beam would be the same of the thickness of the slab. So assumes we have 25 centimeters, okay, or 0.25 meter thickness of that slab, depth of the slab. So I assume the beam is hidden in the slab. It's not dropped. So I have 0.8 width by the thickness of the slab to be 0.25. Okay. Okay, so I assume the slab is hidden. Okay, the beam in the slab is hidden. So I have 0.8 width of the slab per 0.25 meter, which is the thickness of that beam that has the same depth or the same thickness of the slab. And then I can choose like 28 megapascal for the beams to be the same as the concrete for the slab. So I can define the depth and width. For example, 25 and here 80. Okay, and make sure it is like this. And then the modifiers for the beam according to ACI to be 0.35. So make sure the moment inertia about 2 axes and 3 axes. Also the torsional constant to be 0.35 stiffness. Okay. So the modifiers to be 0.35, 0.35, 0.35 for the beams according to ACI standard. This is the stiffness modifiers to be for the beams. Okay, so make sure it is 0.35 for the torsional constant, 0.35 for point, again 0.35 for moment inertia about 2 axes, 3 axes. Once you did that, just click no and go to the reinforcement window. You need to make sure it is a beam, and the clear cover or cover to the center of the bars would be the clear cover defined by ACI code for beams. It would be 4 centimeters or 40 millimeters. And because we have a stirrup, it assumes the stirrup size to be 10 millimeter, so we have 50. And also we have a diameter of rebar, it assumes in the column, in the beam, would be 20 millimeters. So we will have the half to have the distance to the centroid or to the center of that rebar. So we have also an addition 10 millimeters. So we have 40 clear cover and 10 millimeters to be the stirrup size diameter, and another 10 millimeters, the half of the diameter of the main reinforcement in the beam. So we have 60 top rebars and bottom rebars would be the same for cover to the center. Okay. And let's make sure the longitudinal rebars and also the confinement to have the same grade 6 yielding stress of 420 megapascals. So click on OK. And here we defined everything. Okay. Perfect. Now we would like to define the load combination. But before that, let's define the load case. So define the load case. Have the live load, the dead load, and the model. So it's already defined. Also, we'd like to define another. Before the load combinations, we need to define the load pattern because we have dead load, live load, and also we'd like to add a new load. Sorry, just like there. So I would like to name it super dead and just choose the super dead and the self multiplier to be 0 because I would like to add that super dead. I don't want the ETABS solve or compute that load by itself. For dead load, yes, the self multiplier is equal to 1 because I need ETABS to compute the dead load, okay? On structure, weight, and so yes, just after you name it, add a new load. So it's already given. Perfect. Now let's define the load combination. Define load combination. I can add default design combination. Just click, and it is a concrete frame design. Click on it. I have already the two load combinations. And if I hover in the first one, I can see it is 1.10, 1.2 dead plus 1.65 and plus 1.2 super dead. Dead and super dead are the same kind of load. I can just also modify it. Okay? But I cannot modify the name because it is already by default. So if you would like to define or to change the name, you can make a copy of that. And let's define it as like 1.2 dead plus 1.5, just to make sure that I'm understanding what is that load combination. Okay. And I think it is the second or the first load combination to be 1.4 dead. So, and this would be the 1.2 dead plus 1. Okay, plus 1, 6, 5. Dead refers for the dead load and also for the super dead load. Okay, perfect. So everything is clear now. I can also just delete the combination. So I have already my combination. Now, okay, perfect. So I draw everything. I defined everything. I didn't draw anything. So let's get started with designing or modeling. For designing, we'd like to model the structure. We defined everything. I can go here, quick draw columns, and I can do like this. Just hover. Already it's created. For that, we are in story 4. We go to the story 1. And then just hover like this. And before that, change the property to have the column 0.4 by 0.4. Just drag and drop this. Perfect. Here are our columns. And also we can click in the 3D and make extrude. Extrude. See them. Perfect. Now let's define a slab. Go to define menu and go to the slab sections. Find a new property and let's make it ripped 0.25 meters, for example, and choose it to be shell 10 and then modify the modifiers. The modifiers would be 0.25, 0.25, 0.2. Okay, it's defined by the ACI. Then I have the slab be ripped, and here the overall depth to be 250 millimeters. The topping would be 10 millimeters, 10 centimeters, or 100 millimeters. And this is the ribbed width to be stiffens from 12 centimeters to 15 centimeters, 10 centimeters at least. So it's okay. I need just like this. and the center to center ribs spacing or rib spacing be 900. And again, it's depend on the size of the block, the ribbed block. I will explain these informations later, but I just like to keep on the concept how to find the slab property, make the model just for. And this is the ribs parallel to, I mean, just the direction of ribs depends on the way of the um, load transferring from slab to the beams and so forth, depends on the direction of loading. One way we have way, and one way it depends on the axis, and it depends on the main beams, it depends on the secondary beams. Let's get started for now and just continue. I will explain these things later. And also you can view my YouTube tutorial for ETABS, 2.5 hours explaining everything regarding the ETABS modeling, designing a real example for building up to the end of design results and also a job draw. So let's click on OK. And okay, we define that slab. And we need to click in this rectangle and choose the slab that we need to draw, which is 0.25 meter thick. Just click in the grid point A. Just click in the last grid. Now we have already defined and draw the slab. But before that, or we can do like this. We didn't draw the beams. So we can draw the beams and then draw the slab. Okay, so let's make Ctrl Z. Now let's click in this beam, in this draw to the beams and choose the frame to be our beam. Now the draw strategy is to be from the left to the right, from bottom to the top. Okay, and this is very important. For that, just expand this window. This perfect, and again draw. Select the first one. Okay, and just again first grid point and to the last one, just right click, then left click. Okay, right click. Let's try another option, another method for uh, replicating things and drawing things in the model. After I select it like this, I make Ctrl R. Okay, Ctrl R. Then I click in the big 2 points. I click in the first one, click in the last for the second one. I need to replicate this beam from this point, the grid point A4. Okay, then just hover and OK. I can see the result before I click on up. If it's OK, just click on up or OK. Perfect. Now we draw in the X direction. Now we need to draw the beams from for the Y direction. Also, from the bottom to the top, the methodology is very crucial and very important in designing, and the analysis results would be different if you didn't follow this strategy, because the mesh and the analysis would be have a lot of issues. Now also Ctrl R. For that, just I need to make the number 1, 2, 3, 3, because we have the same dimension or the same distance, 8 meters. So I need just to replicate this beam into 3 beams at the same 8 meter, and then just click and choose the big points. The first point, second point, just click on OK, and perfect. We draw everything. Now let's draw the slab. This is the rectangle, first point, and just this is the first point, and this is the second. Perfect. So we draw the first floor. Now we can select everything. For that, we need to assign the loads. So select the slab, then go to assign menu. Assign this slab is a shell in ETABS. Okay, so shell loads uniform. Let's define from live load to have 2.5. Okay. Live load. Okay. After that, we can go here for previous selection. So I select the slab, last selection, select again super dead, and make it 4.5 for it, and then click apply. Now to check if we define the loads correctly, click in the slab and right click, then go to loads. So it's defined already, live load and super dead load. After everything is clearly defined and assigned, select everything, make Ctrl R, then go to story and select the 2, 3, 4 because we define the base and the story ones. So we need to replicate everything to the other up stories. Taken okay. Perfect. So we already model building. Please, guys, if you like this video, tutorial, just let me know in the comment section if you have any questions. And also, if you didn't subscribe to my channel, I really recommend you to hit that button, subscribe to my channel, and you will be happy for my tutorials. I will be happy because you are engaged and you see my video is helpful for you. And also, if you have any questions or you would like to have a private training with me, just book your trial lesson. I will give you the link for my WhatsApp in the comments. Have a nice day.